Projection horizontally. We will learn about one type of projection, which is horizontal projection. As we see in this example, so we have a person throwing the ball horizontally at an initial speed with value u. If we want to divide the initial velocity between horizontal and vertical component, we can see that there is no vertical component, only horizontal. So alpha, which is the angle that the ball creates with the horizontal force, is 0 degrees. Since alpha is 0, this means that the equation for the horizontal and vertical displacement are as follows. H equals ut sine alpha minus half gt squared. Alpha is 0, sine 0 is 0, so all of this is 0. H becomes minus half gt squared. While the horizontal displacement is still S equals ut cosine alpha. Alpha is 0, cosine 0 is 1. Here there is an equal sign. This is a mistake from the book. So S is equal to u times t. These are the equations of the vertical and horizontal displacement. They are represented on this graph that we have below, trajectory. This is how the path of the ball looks like. It is the blue line on the graph. It is like a parabola. The force affecting the ball can be seen on the force diagram, which is the weight. The acceleration here is vertical. The horizontal speed will not change. That means the vertical motion is what will accelerate. The vertical motion and the horizontal motion can be considered quite separately. This leads to the surprising but nevertheless true conclusion that the time of flight, which is the time taken for a dropped object to reach the ground, of an object is the same whether it is dropped or projected horizontally. In both cases, the initial vertical component of velocity is 0. For example, if there is a cliff near the water and the person throws the ball vertically downward from here and throws another ball horizontally at the same time, it will have a trajectory of a parabola like this. The two balls will reach the water surface at the same time, so t is the same, even though one ball was thrown vertically while the other was projected horizontally. They both have the same acceleration, which is acceleration due to gravity. This is what is meant by time of flight, which is the time taken for a dropped object to reach the ground, of an object is the same whether it is dropped or projected horizontally. Another example is monkey and hunter. The monkey is here moving vertically downward, while the bullet from the gun is moving horizontally like this. If the monkey drops from the branch at exactly the same time as the bullet is fired horizontally at it, the bullet will hit the monkey. The time for both of them to reach here is the same. This is because both monkey and bullet have the same downward acceleration.